Hey everyone, today we're going to be talking about homework number 12, which was all about section 8.2. So this section was all about properties of exponential functions. So first couple problems you guys have for today are literally just graphing a couple exponential functions. So I want you guys to go about this the exact same way you did in homework number 11. So let's just go ahead and make up an example. So the first one you have is negative 5 to the x, so let's just do y equals negative 4 to the x. So the first thing we need to realize when we're doing these problems is actually that the negative sign doesn't go with the 4. 4 is your b value, and actually your a value is negative 1. So actually we can rewrite this equation like this. That's going to help us when we actually start plotting some points. So I want you guys to go about these problems just like we did in the last homework. You're going to draw me a little data table, x, y, and you get to choose 3 points that you're going to graph. Make it easy for yourself. Choose 0, 1, and 2. So when we go ahead and plug these x values in, for 0 we're going to get y equals negative 1, 4 to the 0th power. So remember, when we do anything to the 0th power, that's just 1 itself. So this whole thing just becomes 1. So now this equation just becomes negative 1 times 1, or negative 1. When we go ahead and plug in 1 for this equation, we'll get y equals negative 1, and then 4 raised to the first. So when we do this, 4 raised to the first is just 4. So this equation just becomes negative 1 times 4. Negative 1 times 4 obviously just gets us negative 4. Okay, so when we do our last one, we're just going to do y equals negative 1, 4 squared. Obviously, 4 squared just gets me 16. 16 times negative 1 gets me negative 16. Alright, so now we're just going to simply graph this thing. Our first point is at 0, negative 1. So I'm going to go over 0 down to negative 1, and we have our first point. Second one's over at 1, negative 4. And then we have our second point. Then we go down to 2, negative 16, which is all the way down here, and we're seeing an exponential function that looks like that. Let's just pretend I hit that line right there. Perfect. So that's how we're going to go about graphing 1, 2, and 3. Alright, for the last two problems today that are on our homework, all you're doing is using the transformations that we talked about in the lesson. So remember, our general form of this equation, the exponential equation, is y equals a b raised to the x minus h plus k. So the big things here to realize in these problems, we're just talking about h and k. So if you remember from our lesson, k values were just our vertical shifts or vertical translations. So say if k is something like plus 4, that just means we're shifting up 4. If it's minus 6, we're just shifting down 6. And then for h is just our horizontal translations. And just pay attention to the h ones, because there's already a negative sign up here. So if you see like x minus 3, that actually means we're going to the right 3 spaces. Or if you see x plus 9, that means we're actually going to the left, or going left 9 spaces. So just to pay attention with the h, because it's going to kind of do the opposite of what we would normally think. Alright, so now we're going to go to questions 18, 20, and 21 on your guys' homework. So for these ones, we're simply just going to plug these into our calculator. So I'll just kind of show you the calculator strokes. So if we're doing, let's say, e to the 4th, in your calculator, what that would look like you're going to do the second ln button, which is going to give you e to the, and then you're just going to type in 4. Simply press enter, and that'll pop out whatever your answer is. So just go through those 3. Should be pretty simple. Just use your calculator for those ones. Alright, now let's jump to questions 24 and 26 on your homework. So to help you guys out, I'm going to do question 25. So on question 25, it says we have a principal of $400. It says we have an annual interest, so I'm going to say interest rate, or just R, of 7.6%. And we're going to be waiting a time, or T, of 1.5 years. So on this problem, remember, the compound interest, the continual compound interest equation is A equals PE to the RT. So on this problem, we're really just going to kind of just plug everything in. So I'm just going to start plugging everything in. I'm looking for A, or how much money I'm going to have in my account. P is my principal, so the money I start with, which is $400. E, remember, is just the natural exponent, so it's just a number. R is 7.6%. So this is the one that gets a little tricky. Remember, we don't actually ever use percent form, we're going to use decimal form. So I'm going to use 0.076 here. And then for T, we've got our time of 1.5 years. Alright, now that I have everything plugged into my equation, I'm just going to start solving some stuff. So remember, we have to follow our order of operations. So we're going to start up in the exponent first. So I'm going to do this calculation of 0.076 times 1.5. So that's going to end up with, we haven't used our 400 or our E yet, and 0.076 times 1.5 is going to get me 0.114. So next we're actually going to do E raised to the 0.114 to help us follow along with PEMDAS. When you do that calculation, we will simply get A equals 400 times 1.1207. I'm just going to round it off at 1.207. So next, our last calculation, we're just going to do 400 times the number we just calculated. So now when I do this calculation, I will get my count. A just has a balance of $448, and I'm seeing 0.300, so I get and 30 cents. And that is all I've got to do for that problem. Alright, so now we're going to talk about question 41 from your homework. So this is definitely the trickiest problem on here. So in this question it says an investor withdraws all $525 from an account that was neglected for 8 years, meaning you didn't touch your account for 8 years and just let it build interest. For this question, it says it earned 3.4% annual interest, compounded continuously. How much was the initial deposit? So I'm going to change the numbers, but I'll kind of walk through this problem for you. First thing you guys need to realize is we're using the continuous compound equation, which is A equals PERT, or the PERT equation. Just like we did for the last set of problems. So this one's going to be a little different because I'm going to give you the ending result, and we're going to be solving for the principal, or how much we put in at the beginning of our bank account. So for this example, I'm going to change a couple numbers, and I'm going to say the investor withdraws, let's say $450 instead of the $525. And we'll say neglected for 6 years, so T equals 6 years. And we'll use an interest rate, or R, of, let's go ahead and say 4.5%. So the first thing we got to do is just simply set up our equation. So I know in the end I ended up with $450. So that would be my A value. So I say 450 equals, I don't know my principal, that's what we're looking for. E raised to the R, remember, decimal form. So 0.045 times T, or 6 there. Alright, so now we're just going to go ahead and start solving this thing. So I know we have this P over here, but everything else on the right side is just some numbers. So we're just going to start calculating everything we can. So first thing we're going to do again is start in the exponent. We're going to do 0.045 times 6. When I do that, I'm just going to be left with 450 equals P e to the 0.27. Okay? Our next step, we're going to do this calculation, e raised to the 0.27. When I plug that into my calculator, we're just going to be left with 450 equals P times 1.3099. I'm just going to round it off at 0.99. 4 decimal places should be more than enough information here. Alright, so our last step here is to just get P, or our principal, by itself. So remember, when we're solving an equation, we're just going to use an inverse. Right now I see that we're multiplying, so to undo that, we're just going to divide each side by this number over here. When I do that calculation, I will just get my principal P equals about $343.54. So my decimal is actually 537, but that 7 is bigger than 5, so I'm going to round it up to 54 cents. So this is what I initially put into my bank account.